Hey everyone, in this video we are going to look at path attribute manipulation. Okay, so when BGP sends advertisements to other BGP peers, sebenarnya dia hantar dua benda yang penting dalam route advertisements ni, which is one, network layer reachability information or NLRI. So dalam NLRI terkandung information mengenai all the networks that are available to that particular router ataupun BGP peer. So dalam ni dia ada dia punya network address ataupun kita panggil network prefix bersama dengan subnet mask ataupun prefix length. Okay, so senarai network prefix dan prefix length ini adalah senarai network that are reachable daripada diri dia. Along with this NLRI, it will also send the path attributes, which are attributes yang boleh membantu atau mempengaruhi router untuk buat decision which is the best path. So, antara benda yang dia hantar adalah origin, AS path, or weight, and etc. Yang kita akan tengok in this video. Some of these attributes you have already seen when you created or configured the basic BGP, multipath BGP, and you've seen this in the BGP table. So, untuk BGP, proses untuk pilih the best path adalah lebih kompleks daripada EIGRP dan OSPF. Kalau EIGRP, dia punya metrik adalah distance, and OSPF punya metric adalah composite metric like bandwidth, delay dan sebagainya. Untuk BGP, secara default dia akan pilih the best path which is satu sahaja, tak ada multipath. So cara dia go through the best path adalah the first one, it will look at the prefix length. Maksudnya dia akan cari the best path yang mempunyai prefix length yang paling panjang ataupun yang paling spesifik. Yang kedua, dia akan tengok administrative policy. This means kalau ada administrator yang buat or configure policy based routing, for example route maps, dia akan tengok route maps tu dulu. Kalau tak ada, then it will go to the attribute list and it will go down the list one by one according to the sequence. So the most important part in this video adalah we want to look at the attribute list. So barring that, yang sebelum-sebelum ni ataupun condition yang sebelum seperti prefix length dan juga route map tak boleh digunakan untuk mencari the best path. Jadi the BGP router akan gunakan attribute list untuk cari the best path. So untuk Cisco, dia mungkin berbeza dengan vendor yang lain sebab dia ada dia punya own proprietary attribute. Okay, so kita go through one by one. Sebelum tu, kita tengok in general, all these attributes can be categorized in a general category sebagai well-known mandatory, well-known discretionary, optional transitive, or optional non-transitive. So, untuk well-known, okay, it should be supported by all the BGP implementation. So, any vendor or manufacturer that wants to participate in producing BGP enabled products, they should be able to support all the well-known attributes. So untuk well-known ni pula, dia can be either transitive or mandatory or discretionary. Untuk mandatory, that means it will be advertised between the AS. Untuk discretionary, it will not be advertised between the AS. So, selain daripada well-known ini, it is optional. That means it may not be supported by all the BGP implementation. So, it depends on what vendor or platform it is. Okay, dan juga dia samalah, sama ada transitive or non-transitive. So, itu mengambil kira sama ada it should be advertised between the AS or not. So, the diagram shows some of the attributes. untuk diagram ini, nilai dia adalah untuk relevant to Cisco lah. Maksudnya kod-kod ini diberi untuk diletakkan dalam BGP punya packet untuk nilai attribute. So let's look at the first attribute. The first attribute is weight. So weight is a Cisco proprietary attribute and it is discretionary, so it's not advertised to other routers. It's non-transitive lah. Okay, so this is one example topology where the router 4 and router 6, we can influence how router 4 and router 6 makes a decision about the best path bila ada jalan nak ke destination 172.16.0 or 172.24.0. So basically R4 and R6 wants to influence the outbound traffic by using or setting the attribute on inbound route advertisements. Okay, so for example here, like I said, we have these three destinations. What we want to influence adalah untuk 16.0 and 24.0. So kita applykan kepada inbound route advertisements. So let's zoom in for a while on the configuration example on router 4. So we want to influence the path untuk nak ke network destination 16.0. So we set this IP network or network prefix as one of the access control list. Okay, so kita panggil ni sebagai pre-172 and permit this family or network prefix. Next, we want to get a list of match and set dalam kita punya route map. So kita nak match this IP, and bila jumpa this IP punya route advertisements, we want to set the weight as 222. So the default value for weight is 0. Okay, once selalunya is not set, and then we want to set the value can go from 0 until 65536. Okay, it's because this attribute is 16 bits long. Okay, so now let's assume sebab kita just nak influence bagi one value 222. Okay, so our PBR we need to apply dekat somewhere. So kita apply dekat whatever advertisements that is inbound. Okay, so nampak keyword sini inbound. Anything advertisement that is coming from AS200 inbound to router 4 or AS400, then we match whether there is an advertisement for network 172.16 and set the weight as 222. So essentially here we want to influence macam mana router 4 pilih the best path bila ada jalan nak ke network destination 172.16. So kat sini router 4, router 5 and router 6, they are connected through iBGP dalam AS yang sama. Okay, jadi it's bound to have an advertisement daripada router 6 juga mengenai network 172.16. So that's why we want to influence our decision. Datang daripada sini satu advertisement, datang daripada sini juga satu advertisement. So the same goes for router 6, except dekat router 6 dia punya configuration adalah apply kepada 172.24 and dia weight dia letak 333. So now let's zoom in on the results after that. When we view the BGP table for router 4, for the destination network 172.16.0.0, there will be two possible paths. One melalui 192.168.6.6. So this is the loopback IP connecting from router 4 to router 6, this IP, right? So the metric is 0, the local preference is 100, and the path is 300 and 100. That means lalu sini lah. Okay, router daripada sini untuk pergi ke 172.16 dia kena lalu sini 300 and then 100. Okay, so notice there is another attribute here. Local preference is 100. So let's assume that this value has been set by router 6 because by default local preference tak ada value, cuma dia boleh disebarkan or it can be advertised among IBGP routers. So let's assume that router 6 has advertised this network, okay, with a local preference of 100. Okay, so local preference may be advertised among IBGP neighbors. Then kita ada path yang kedua nak ke 172.16 which is melalui 10.24.1.2 which is melalui sini, router 2 lah, right? And we have set, router 4 has set the weight as 222. Okay, so sekarang kita ada dua attribute. Okay, but bear in mind among all the attributes, weight adalah nombor 1. Okay, jadi kat sini untuk kita tengok lah, katalah kita tengok at first glance, the AS path adalah sama, yang lain origin dia adalah sama, kita ada local preference dan juga weight. Okay, going down from the list, number 1 adalah weight, jadi weight has more priority, so the router 4 will select the best path as this path melalui router 2. Jadi kalau router 4 ada destination nak ke 172.16.0, dia akan pilih menggunakan AS200 baru sampai AS100. Okay, let's look at the next attribute which is local preference. So local preference is also not advertised to other autonomous systems, and the default value will be 100. So for example, among the IBGP, if this is an edge router, if it receives an advertisement for an outside network prefix, it will automatically set the default value to 100. Tapi untuk topologi ini, kita nak supaya influence jalan nak keluar untuk ke destination network 172.16 daripada R4 will be through router 2 or AS200. Untuk router 6, jalan keluar ke network 172.24. All other paths ataupun prefix will follow the attribute list lah, right? So example topology ini, kita set local preference dalam kita punya route map sebagai 333 untuk 172.24. So ini configuration example dekat router 6. So this will be the BGP table after setting the local preference. Let's zoom in on router 6 and also router 5 as a benchmark. So if you look at router 6 punya BGP table, you will find that there is only one possible path for network 172.24.0.0. Okay, so bukanlah it's being deleted atau apa. So there are several phases dalam setting the local preference ni bila kita advertise among the IBGP peers. So kalau dekat router 6, for the first time when we set the local preference, so dalam BGP table dia akan mempunyai satu entry to the network 172.24.0.0 which is through itself, alright. So 10.36.1.3 tu adalah melalui router 3. Okay, so kita dah set local preference to be 333 if any advertisement for 172.25 inbound melalui router 6. So fasa kedua, router 6 akan terima route advertisement for 172.24 daripada router 4. Okay, and it will automatically set the default value of local preference which is 100. So between 100 and 333, we are looking for the higher local preference. So here, the router 4 will send a withdrawal, right? Remember BGP packet ada satu adalah untuk withdraw certain path. So router 4 will send a withdrawal for this path mengenai 172.24 kepada router 6. So that's how we get, there's only one entry for 172.24 melalui router 6. So the next hop will be router 3. let's move to router 5. Okay, so whatever is being advertised by the iBGP router, it will be entered inside the peer yang diterima. Okay, so for example here router 4 advertise 222 untuk 172.16, 333 untuk 172.24. So this is being advertised by router 6 and this is being advertised by router 4. Okay, so sama juga dengan yang sebelum tadi, router 6. So maksudnya router 5 will get the advertisements and it is being advertised from router to router within 1 AS. So dia akan dapat 222 dan 333. Jadi dia akan pilih the higher local preference, right? So there is a withdrawal for the other path from router 4 and router 6. So you get the best path for 16 here and this is the best path for 24. Untuk 172.20 kita tak ada set apa-apa local preference, so the default value will be 100. In this case, dia akan go through the attribute list. Okay, just for going through the attribute list purposes, kalau kita compare yang ini, alright, so sebenarnya kita ada value yang sama, metric 022, local preference 22 100, weight 22 0, then the AS path 22 kena melalui 2 AS, then the origin also interior gateway protocol. Jadi what will be the tiebreaker? Okay, so kita go through weight tadi 0, local preference 22 100, then prefer the route originated by the local router. Since this is not being advertised by router 5, then ini tidak dikira. Yang 4, this is not enabled by default dan tak ada lah, kita assume by the output it is not set by the administrator. Prefer the shortest path, AS path, ini sama kalau kita tengok tadi. The origin code is also I, jadi dua-dua sama. MAC is not set. In external and internals, again this is internal yang sama. Prefer the path through the closest IGP neighbor. So the closest, kalau tengok topology, it is the same. Prefer the oldest route for eBGP and with the lowest neighbor ID. Okay, so let's assume kita tak ada information mengenai oldest route sebab kita tak boleh tengok timer. The next best thing untuk decide adalah the path with the lowest neighbor ID. Right? Dan kita tak ada, let's assume that the neighbor ID is gotten from the loopback address. Kalau kita tak set lah, okay, sebab kita tak ada information whether the router ID has been set. So this will be the highest loopback address. Okay, so the next best thing then adalah the lowest neighbor IP. So these are the possible tiebreaker. Dan here kita tengok the next hop IP, the neighbor ID adalah 66 dan 44. Jadi kita akan ambil yang rendah, the lowest, which is 44. Then untuk dua path ni, possible path, this will be selected as the best path. Okay, we go through the list again. Number 3 is locally originated in the network, which means kita yang advertise menggunakan network command ataupun aggregate advertisement, maksudnya kita yang set the summary advertisements. Okay, selepas tu baru kita ambil routes received by BGP peers. Next is lowest AIGP. Okay, so ini selalunya by default is not enabled. Dia akan being enabled by administrator dan bila keadaan yang sesuai adalah bila kita adalah for example service provider. Okay, so we have multiple interior gateway protocol, for example EIGRP ke OSPF ke daripada kita punya client, and we want to set as a seed metric yang mana yang lebih rendah. Okay, so for example here from AS100 there are IGP routing protocol yang ada, so dia akan paskan the path matrix kepada AS200. Let's assume this is the ISP. Jadi untuk dia distributekan path ni, dia sendiri yang akan letak the AIGP value untuk setiap satu path ini. Next attribute is the shortest AS path. Okay, so by right, the list of AS adalah based on whatever we configure during the neighbor relationship configuration. So that means apa yang dia kena traverse adalah mengikut the AS yang telah kita set. Untuk kita mempengaruhi AS path, we basically can prepend a value for the AS. For example, kita akan pilih the shortest path. So untuk kita mempengaruhi the opposite, kita tambah AS list. Okay, so ni dipanggil prepending. So for example here, configuration dekat router 4, sebab kita nak jalan untuk keluar ke destination 172.24 melalui router 6, right? Jadi kita nak mempengaruhi apa-apa advertisements daripada router 2, which is AS200, supaya dia kalah. So untuk kita kalah tu, kita setkan the AS path ada tambahan. So kita bagilah AS number 222210 ni. Okay, so let's assume this actually does not belong to anything, so it's unique. So kita tambah dekat AS path yang datang daripada router 2. So whenever there is a comparison between advertisement daripada router 2 ataupun router 3, okay, the router 2 will lose lah untuk nak ke destination network 24, sebab kita nak dia menang melalui router 3. So the result will be, when we advertise, okay, router 4 ni dia hantar advertisements to router 6 untuk that particular network, then it will have an extra 333 and 321. Next attribute is the origin type. Okay, so origin basically value dia yang kita tengok dalam BGP table adalah I, E ataupun question mark. So I stands for whatever advertisements yang kita advertise menggunakan the network command. E is whatever advertisements that is received from an exterior gateway protocol, which is the BGP, next AS. And question mark is from other sources of routing protocol, for example through redistribution. So again here kita nak influence the path taken. So if you see tadi benchmark dia dekat router 5, we'll see that origin will be the same, which is I, because it's distributed from the IBGP neighbors. Okay, so now kita nak influence the path for 172.24 and 172.16. Okay, as always, yang ni akan lalu untuk destination 172.16, yang ni akan lalu untuk 172.24. So we influence the opposite path, which is 24 and 16, dengan set the origin as incomplete. Sebab incomplete ni adalah yang paling last lah antara tiga, I, E dengan question mark kan. So question mark will be the last one dipilih. So you set the origin as incomplete untuk whatever advertisement for network 172.24 yang masuk ke sini. So the result will be the BGP table for router 4 will have an incomplete origin. Therefore you will select here lah, this is the best path, maksudnya melalui router 6. Next, let's look at multi-exit discriminator. So macam nama dia, multi-exit. So basically sebenarnya this is one attribute where we specifically set if we have to choose between two exit points. For example, untuk AS400 ni ada dua exit points, lalu sini ataupun lalu sini. Alright, so dalam multi-exit discriminator or MAD, we want to look for the lower value or the lowest value. Right, so kita compare, for example, when we set the MAD value for 172.16, 140 untuk lalu jalan ini dan satu lagi 80 untuk lalu jalan ini. So the BGP will select the MAD with the lower value. So this is the result of the BGP table. Bila kita dah set the match value antara 40 dengan 80. 40 will win. So jalan for the network 172.16 will have the entry untuk 24.1 di sinilah. Untuk router 6, again it will select the best path between 40 and 80 is using 4.4. Okay, so compare pula untuk 24 between 10 and 90. So 10 will be the winner lah. So something that we need to remember adalah when we have MAC set, okay, dan ada certain network yang kita tak set the MAC, okay, dia punya default behavior adalah if a MAC is missing, the path without a MAC is preferred over a path that contains a MAC. So dalam case ISP, okay, mungkin kita set MAC hanya untuk dua path daripada ISP yang sama, okay, because that's the behavior when we compare the MAC. It is to to break a tie between path advertisements that is coming from the same AS path. So katalah ada salah satu path tu kita tak letak, alright, so that automatically becomes the best path, and we do not want this behavior. Kita nak apa-apa path yang kita tak letak MAC tu sebagai tidak dipilih. Then we can set the command with using BGP Best-path MAC missing as worst. Okay, so this will change the default behavior. Mana-mana path being advertised without having a set MAC will be the worst. So BGP speaker akan letak value yang tinggi lah, okay, sebab kita nak MAC yang rendah sebagai the best path. Another way that we need to modify the default behavior of the MAC adalah between two AS. So again, like I said, the MAC will only be compared when we have two paths coming from the same AS. For example, katalah antara router 3 dan router 2, kita ada dua path, okay, nak ke router 5 ni, right? So router 5 will have to choose between this path and this path, alright? So the MAC will play a role. Tetapi katalah kita ada daripada dual multi-home, maksudnya ada ISP 1, ISP 2, dan antara satu ISP tu ada dua link, okay, lagi satu ni ada satu, just for reference. Then katalah the MAC advertisement comes using this sequence, maksudnya MAC ni sampai dahulu, okay, so satu advertisement nak ke network 60 ni sampai daripada AS 300, okay, and the MAC will be 200, okay, so the AS path yang datang daripada sini adalah 300 dan 100. Kemudian kita ada advertisement daripada sini which is 172.16, MAC dia 100 dan melalui 200 dan 100. Okay, so let's assume that this MAC was intended for this path to be chosen. So kalau kita compare yang ini dengan yang ini, kita tengok mungkin kita kata ni lah menang. Okay, tetapi that's not how the BGP behavior is by default. Dia tengok juga the AS path. So kalaulah 300 and 100 dengan 200 and 100, it will not compare the MAC. Dia hanya akan compare kalau dua advertisement yang sama ke network yang sama daripada AS path yang sama. So for example here, between here and here, it will compare and 100 will win. Tapi kalau yang ini dengan yang ini, dia tak akan compare. That's how it behaves by default. Kalau kita nak, katalah ada dua ISP, okay, dan kita nak always supaya this AS lalu jalan keluar by default lalu sini dulu. Okay, mesti pilih 200 ni dulu, lalu sini dulu, barulah kalau ada something wrong with this AS, barulah lalu sini. Then kita kena set the always compare MAC feature. So regardless of what the AS path is, always compare the MAC to determine the best path. Okay, so ini untuk kalau kita set multi-exit discriminator. Next is the comparison between eBGP over iBGP. So eBGP peers punya advertisement will be the most desirable. Then a confederation member, maksudnya wakil, ataupun last kali baru iBGP. Next is the lowest IGP metric, right? So this is within the AS. If we have an IGP neighbor relationship, then it will select the path with the lowest IGP metric. Then it will prefer the oldest eBGP path. This is for stability, sebab kalau dia selalu bertukar-tukar path dia, maksudnya that path is not stable, right? Then kalau advertisement tu datang daripada path yang sama, then it will look at the lowest router ID of the advertising eBGP router. And finally, if we have two, maksudnya kita advertisement daripada dua router ID yang sama, then kita akan tengok the lowest neighbor address. Okay, so that is how BGP determines the best path. Ada banyak metric dia lah. Okay, so dia ada attribute list lah. Sebenarnya kita tak panggil dia metric in particular, but they select according to this list of attribute.